Hey everyone, in this video I would like to look at an application, a word problem that involves some of the things we've been working on. So some first part of the fundamental theorem, and some average value, things like that. Excuse me, I still have a terrible sounding cough going. Okay, so we're given a function, v of t, and this function is supposed to tell us the value of a Tiffany lamp t years after 1965. So Tiffany lamp, fancy glass shade lamp, they cost way too much money. This might not be fully realistic, but they really are expensive lamps. So first thing we're supposed to figure out is what is v of 0. So no derivative, no antiderivative, just plugging 0 in. And if we plug 0 in, 225 times 1.15 to the 0. 1.15 to the 0 is 1, so we're just getting 225. T years, find the value. Okay, so nothing weird on this. In fact, bad on me for not saying, but let's assume that the value is in dollars. So, explain its meaning. Okay, so this says that 0 years after 1965, please simplify wording whenever possible. So I would say in 1965, the lamp's value was $225. Okay, so our function inputs number of years since 1965, outputs the value of a lamp in dollars. Now we're going to get into the calculus part. So this first one, second one I guess, part B, is a Calc 1 question. So we want to know the value of v prime when t equals 50. So first thing we're going to need to do is find v prime. And our function was an exponential function. I have it hidden from you now. 225 times 1.15 to the t. So its derivative is going to be exactly that with one little extra chunk. Okay, so when you take the derivative of an exponential function, you get the exponential function multiplied by the natural log of the base. And again, e is the special case. This rule still applies, but the natural log of e is 1, so it looks a lot prettier when we're done. If we then want to find v prime of 50, we're going to plug 50 in here. Okay, and I'm going to sidetrack because unprepared me didn't think about plugging this in ahead of time, so you didn't have to wait. So 225 times 1.15 to the 50 times the natural log of 1.15. Assuming I type that in carefully, I get approximately 34,077.17. Okay, so thinking units on this, our v function inputs years and outputs the value in dollars. So our v prime function is going to be a slope, which is going to be dollars per year. So the meaning of this, let's see, we were starting in 1965. So in 2005, wait, am I counting wrong? I'm counting wrong. In 2015, excuse me, 2015, the lamp's value is increasing by $77.17 per year. Okay, so this is one possible wording. You could also use it as a predictor of what's happening during that 1 year. So slightly different wording would be during 2015, we expect the lamp's value to go up by approximately $34,077. This is using the slope of a line to estimate something that's curved, so we don't expect it to be perfect, but that's approximately what it's trying to tell us. Okay, so now part C looks like it's actually a Calc 2 question. So if we want to integrate v prime of t from 35 to 50, we want the definite integral. Remember that the steps for finding a definite integral, oh, and if you haven't already, please pause and try some of this on your own, are first find the antiderivative, then evaluate. So even without writing the equation in, I can kind of nicely walk my way through what needs to happen. So we're going to take v of 50 minus v of 35. V of 50, hold on, let me sidetrack again. I have most of it plugged in. Okay, so 50. Okay, so v of 50 is about 243,822.92. V of 35 is about 29,964.49. Oh, not smart teacher didn't save those numbers in my calculator. So let me just plug in. So we're going to subtract. And, okay, so 243,822.92 minus 29,964.49. And I'm getting that this is approximately 213,858.43. Okay, so that's my value. And then the question is, what is the meaning? And even if you don't immediately get it from the first step, I definitely think we should get it from this third step. That's telling us how much the value changed. What we're starting from, 65. So between the year 2000, and so this is corresponds with the year 2000, and the year 2015. So from the year 2000 to the year 2015, the lamp's value increased by $213,858.43. The lamp's value hold on, let me quietly write out, and then I will say one more thing about this part. 858.43. Okay, so the one more thing I would say is there is this, they call it the Net Change Theorem. It kind of bothers me to give it a name because it's really just the fundamental theorem stated like specifically for the context of a word problem. But I did mention it earlier, and I'll mention it again. It says if you integrate a rate of change function, so this is the rate of change in value that we're integrating, you will get the net change. So if I integrate the rate of change of the value from 35 to 50, I will get the net change in the value of the lamp from 35 to 50, or 2000 to 2015. Okay, so this next part wants me to find the integral of v of t from 35 to 50 and then divide that by 15. So again, I'm actually going to write in the function this time. Zoom a little more. We're going to integrate, here, let me pick a different color since we're getting kind of crowded. Okay, so we're looking for 1/15 of the integral. This time, I don't already have the antiderivative function sitting in front of me, so I'm going to go ahead and write out what this is. If I remember, what was it? It was 225 times 1.15 to the t. Okay, so the 1/15 is just going to hang out in front. The antiderivative of an exponential function this is just the reverse of our derivative rule, right? So when we integrate, we get the exact same thing, but we have to divide by the natural log of 1.15, so that when we take the derivative and end up multiplying by that natural log, it will cancel out. Okay, so we need to take 1/15 of 225 times 1.15 to the 50 over the natural log of 1.15 minus 225 times 1.15 to the 35 divided by natural log 1.15. Okay, and again, boring second while I do calculator. Sometime I might get savvy enough to figure out how to get this thing to show you more than one window, but the recorder I'm using right now is only willing to let me show you one thing at a time. So I need this thing minus, I have a little bit of this stored in my phone calculator, so you won't have to wait for me to type out everything again. Okay. Where did it go? Okay, so if we do that, and then I need to divide by the natural log of 1.15 and by 15. And I think I even got parentheses in the right spot. Oh man, this one makes me so grumpy. 20. Okay. Trying to read my own messy thing and see if it actually worked out right. I think so. I think what I got was 102,010.81. Okay, let me stare at this for one more second because I'm feeling really questionable about my calculators saving the work I did. So that, the 15 to the 35, and then if we take that and we divide it, yep, I think I'm good. If not, please take my interpretation and not my actual number. I will not use my phone calculator next time because it is frustrating me. Okay, so we got that this is about 102,010.81, and we need to think about what this means. So if we think about our v function, this gives the value in dollars, and it's a function of the number of years. So in here, I have value in dollars and I have years. It's really important to realize that there are units attached to that dt. So when I integrate this thing, I'm getting dollars times years, which is kind of weird and not incredibly helpful in terms of figuring out what this means. What's really important is to recognize that we are also dividing by 15. And we're making a little bit of an assumption here, but we're intended to do that in these word problems. So what I'm hoping is that you recognize that this looks exactly like the average value formula. We're integrating over a 15-year time period. We're then dividing by 15 years, which means we're averaging that value out, so the years will cancel, and we're just getting dollars. So this is telling me that the average value, we're going to say average lamp value, from 2000 to 2015 was a lot. $102,000. $102,010. There we go. My brain didn't want to say that for a second. 81 cents. And I think that covers it. Average lamp value from 2000 to 2015. Yep. Okay. So, last question, let me switch back to blue, is what if we take v of 50 minus v of 35 and divide it by 15? So, v of 50 minus v of 35, I think we already got that. Is that true? Yeah. So, in part C, we got that that is going to equal 213,858. I'm going to say approximately. 213,858.43, and then we're supposed to divide that by 15. Okay, not so trusty phone calculator. I want this divided by 15, 858, yes. And I get 14,257.23. And then once again, we're supposed to sort out what that means. And actually, it might be easiest to spot in the form it was already given in, but I do want to point out the integral form of this as well. So we took the change in the value of the lamp over that 15-year time span, and we divided it by 15. So we're getting, the top here is value in dollars. The bottom we're interpreting as the length of the time span. So this units-wise is dollars per year. And if we want to think really carefully about it, what we're getting is the average rate of change of the value. So the value changed by 213,000-ish. If we divide that by the 15 years, that's an average of $14,257.23 per year. We can also think of this as when we went back up to part C, what we were snagging was the value of the integral of v prime of t from 35 to 50, and we then divided that by 15. So once again, this is actually our average value function showing up, but now it's not the average value of the value function, it's the average value of the rate of change function. So this is giving us the average of rate of change. And again, you can follow the units. At first they seem weird. We have dollars per year, and then this guy is years, and then we are dividing by years as well. So in the top, years cancel out, that's great. We just have dollars. But then when we divide by 15, it takes us back to dollars per year. So this one, from the year 2000 to 2015, the average increase in value, so it's not the average of the value, it's the average of the rate of change of the value, was $14,257.23 per year. Okay, so you really want to watch for these averages. I think sometimes people just don't even spot what's going on there. So you want to be able to explain the meaning of an integral. Units can be really helpful. And then if you see that divided by the length of the interval, make sure you're thinking average value. Oh, God. Okay, thanks for watching.